As a supporter of Real Madrid, my favorite color is white. And I know, white is not a color because it is not defined by a single wavelength, but by a combination of all the colors in the rainbow. And we heard from many Epic members there is a growing interest in the business around white lasers. Great reason for an Epic online meeting on Monday, November 1st. Back in 1969, Robert Alfano and Stan Shapiro, working for GTE Lab in New York, shot a green picosecond laser pulse into a piece of quartz and calcite. Magic happened. They discovered almost by accident that the light coming out of the crystal transformed into a wide continuum of frequencies that span from 400 nanometers blue to 800 nanometers red. Because essentially, supercontinuum happens when we have a laser source and a nonlinear element, a nonlinear optical fiber, a nonlinear crystal, a nonlinear photonic integrated circuit, you name it. And you know what? In Epic, we have all that tech. Funny that nonlinear properties of optical fibers have always been a headache. For example, we always wanted to avoid dispersion. When you input a certain wavelength, you want it to receive the same spectrum hundreds of kilometers away. However, highly non-linear fibers are about to revolutionize the industry as the secret ingredient in current supercontinuum generation lasers. Ask the success stories of NKT Photonics or Lucas. So let's explore the applications with the end users themselves. For example, Damae Medical, which have seen supercontinuum generation lasers as the ideal light source for OCT for skin imaging. Furthermore, gas sensing applications are obvious because the goal is to monitor many wavelengths being absorbed by different gases at the same time. With Norbliss lasers, we can reach supercontinuum generation all the way to 10 micrometers in the mid-infrared. Supercontinuum lasers can also be ultra-fast, even operating in femtosecond regime. In microscopy, supercontinuum generation lasers are now the perfect source for CARS, coherent anti-Stokes Raman scattering, and other biotech technologies where we need a pulse diffraction limited laser. And in the academic and R&D sectors, supercontinuum lasers have become the Swiss army knife of all lasers, as they give researchers all the wavelength range they need for their experiments. But there are still many challenges for the present and future of supercontinuum. Can we reduce the size? Can we test the nonlinear fiber in volume? Can we use other nonlinear elements such as photonic integrated circuits? And looking ahead, those working in neuroscience have shown great interest in a supercontinuum laser that could operate in the 250 to 300 nanometer range. That's where proteins, genes, and DNA show up. We still do not know how the brain works. These lasers can help discover how. We want to explore the business cases for supercontinuum lasers between now and 2025. 13 times European champion. And remember, the 1st of November.